Good morning, students. Today we are starting our class with the topic heartbeat and cardiac cycle. These are the words that we are oftenly hearing during our lifetime. Some problems in heartbeat, what are these treatments? So we are going to understand about the heartbeat and what is the cardiac cycle in today's section. First point, cardiac cycle. Simply, in what way we can give a definition to cardiac cycle? It is the cyclic events that is happening between two heartbeats. Heartbeats we know is a up and up sound. But all cyclic events that is happening between two heartbeats. All those events we can call together as a cardiac cycle. In another way, we can tell it as an alternative contraction and relaxation. It is a whole process in which contraction alternates with relaxation, or the process that is leading to this contraction and relaxation. All those processes together we can call as a cardiac cycle. So it's a very important question. It's asked for several time for your university examination for 4-mark question. So listen, for such a question, you first need to give a definition for cardiac cycle, that I have already explained to you. And the cardiac cycle can be divided into main 3 phases. 3 phases are there. Generally, in a simple manner we can tell it as two main changes are happening. First is a period of ventricular contraction and blood ejection. The period is systole and it's followed by, if there is contraction is there should be relaxation. Period of ventricular relaxation. The relaxation period is called diastole. Dia, that term, you listen to that term. Dia means dilation, dilating. As I dilate, the pressure inside the ventricle become lowers, because as the ventricle dilate. So to memorize what's the process happening, what is happening to the pressure during ventricular relaxation. That relaxation, that process is called a diastole, dilation. Ventricle is dilating, so pressure is coming down, lowering. And it's just opposite is systole. Systole is the contraction. So don't get confused over these two terms, systole and diastole. Systole is the contraction and diastole, dilation. So diastole is the relaxation. This is contraction and is relaxation. So we are going to learn about the main 3 phases of cardiac cycle one by one. First is called ventricular filling period, in short form VFP. And this period diastole is happening. Diastole means ventricle is dilated, relaxed. It is not contracted. That we need to understand. So what is the process happening in ventricular filling period? Here I am going to give an image of heart. Heart basic structure is very clear. I think almost all students know about the structure of the heart. 4 chambers are there. 2 auricles, 2 ventricles. And this is the right auricle, right ventricle. This is the left auricle and left ventricle. Okay. And in the right side, impure blood is present. Left side always pure blood is present. And valves are present there. Between auricle and ventricle, semilunar valves present. And from ventricle to the blood vessels, aorta and pulmonary artery is there. For in the opening of these 2 blood vessels, large blood vessel, present again 2 another valves, tricuspid valves and bicuspid valves, to regulate flow of blood from ventricle to this huge blood vessels. The pulmonary arteries carry blood to lungs. pulmonary artery carry impure blood to lungs to get oxygenated, and aorta is there. Aorta is supply again the pure blood to all body parts. This is the basic thing. I'm just remembering you what all the things connecting with the heart. In this juncture, we are going to understand about the ventricular filling period. So many muscular points are there in the heart for regulating the heartbeat. For example, first the initiating point is called SA node. It is somewhat located here. Its location, function, everything we will learn and later in this section itself. So now just listen that SA node, such a point is there in the heart, in the auricle, and in that SA node a electrical signal is initiating, a stimulus impulse is initiating, and in response of that signal, the auricles start to contract. As a result, pressure inside the auricle increase or decrease. When it contracts, if we compress something, the pressure inside will certainly rise. So that also happens here. The pressure inside the auricle steeps because of its contraction. How this contraction happens? As a result of SA node initiates some signal, and in response to that signal, auricles start to contract. As a result of that contraction, pressure inside the auricle rises. As the pressure inside the auricle steepens, the valve between auricle and ventricle open, and blood from auricle is ejected to the ventricle. From here to here, blood is ejected, and also from this auricle to this ventricle also blood is ejected. Right side is impure blood and left side is pure blood. And so that is the diastolic phase. Ventricle is dilating or relaxing that time. The pressure inside the ventricle is very low. This is the ventricular filling period. The name from the name itself we can clear that ventricle filling period, VFP. It's a diastolic period. Next slide. Then next phase, isovolumetric contraction period. It's a second phase. ICP. We can call it as ICP. And it is the beginning. The ventricle just is getting ready to contract. It's not contracting, only preparing for contraction. Okay. And so as it is not contracting, no blood is ejected from ventricle to pulmonary artery or pulmonary aorta. Okay. Instead, pressure inside the ventricle is increasing, and to cross a certain level. And at that level only, the valve that present at the end of this huge big blood vessels will open, and the blood from ventricle is injected or ejected from ventricle to the big blood vessels for carrying to lungs or different parts of the body. So, isovolumetric contraction period. Here, the ventricle just started to contract. Blood is not ejected, but pressure is increasing gradually. Pressure is building up in ventricles. It's the beginning of systole. Systole is initiating, it's not completed. And next phase is called the ventricular ejection period. The term. Listen to that term. In this phase only, ejection, blood from ventricle is ejecting to that huge blood vessels like pulmonary artery or pulmonary aorta. It is a continuation of systole. Contraction is going to happen. Pressure within the ventricle rises. Because of high pressure, the valves open, tricuspid and bicuspid valves open, and the blood from the ventricles ejected to aorta and pulmonary arteries, that huge blood vessels. And the last phase is called isovolumetric relaxation period, IRP. After contraction, after finishing the contraction, then what to do? To relax. For that is the again diastole is beginning. So that cycle from that even start from diastole and again ends up in another diastole. So that it is cycling. All those cyclical events between that alternate contraction and relaxation is called a cardiac cycle. And this isovolumetric relaxation period is called the resting phase. Ventricles again repolarized and all valves are closed. This is about the cardiac cycle. For the question like cardiac cycle, first you need to give definition. Then you need to explain all these phases. 4 phases are there. First I told you that there's only 3 phases. By mistake. So actually there is 4 phases. You need to explain all these 4 phases as answer for that question. So next we are going to see a video showing all these phases and how that blood is ejected to this pulmonary aorta and artery. So let's go and see that video.
The cardiac cycle refers to the sequence of events that occur and repeat with every heartbeat. It can be divided into 2 major phases, systole and diastole, each of which subdivides into several smaller phases. Systole and diastole, when not specified otherwise, refer to ventricular contraction and relaxation, respectively. Reminders: blood flows from higher to lower pressure. Contraction increases the pressure within a chamber, while relaxation lowers the pressure. AV valves open when atrial pressures are higher than ventricular pressures and close when the pressure gradient is reversed. Similarly, semilunar valves open when ventricular pressures are higher than aortic pulmonary pressures and close when the reverse is true. The cycle is initiated with the firing of the SA node that stimulates the atria to depolarize. This is represented by the P wave on the ECG. Atrial contraction starts shortly after the P wave begins and causes the pressure within the atria to increase, forcing blood into the ventricles. Atrial.
This is the first phase that I already explained to you. Pressure inside the auricle is increasing and that blood ejection happening to ventricle.
Contraction, however, only accounts for a fraction of ventricular filling because at this point the ventricles are already almost full due to passive blood flow down the ventricles through the open AV valves. As atrial contraction completes, atrial pressure begins to fall.
Corresponding to all these changes happening in the heart, we are getting the ECG, PQRST waves are there. Again, corresponding to each peak, we have certain event in cardiac cycle. Maybe the auricle's contraction is represented by certain wave that we will explain later in the ECG. Anyway, you listen to this area also along with the description of this video.
Reversing the pressure gradient across the AV valves, causing them to close. The closing of the AV valves produces the first heart sound, S1, and marks the beginning of systole. At this point, ventricular depolarization, represented by the QRS complex, is halfway through, and the ventricles start to contract rapidly.
Here, QRS. This verb represents ventricles depolarization.
Building up pressures inside the ventricles. For a moment, however, the semilunar valves remain closed, and the ventricles contract within a closed space.
Start to contract. Ventricle just only start to contract. The valves remain closed itself. As the pressure exceeds a certain level, certain limit, then only these valves open and blood from ventricles to pass through these blood vessels.
This phase is referred to as isovolumetric contraction because no blood is ejected and ventricular volume is unchanged. Ventricular ejection starts when ventricular pressures exceed the pressures within the aorta and pulmonary artery. The aortic and pulmonic valves open and blood is ejected out of the ventricles. This is the rapid ejection phase. As ventricular repolarization, reflected by the T wave, begins,
last phase is ventricular repolarization. That's represented by the T wave.
Ventricular pressure starts to fall and the force of ejection is reduced. When ventricular pressures drop below aortic and pulmonary pressures, the semilunar valves close, marking the end of systole and beginning of diastole. Closure of semilunar valves produces the second heart sound, S2.
The cycle.
The first part of diastole is, again, isovolumetric, as the ventricles relax with all valves closed. Ventricular pressure drops rapidly, but their volumes remain unchanged. Meanwhile, the atria are being filled with blood and atrial pressures rise slowly. Ventricular filling starts when ventricular pressures drop below atrial pressures, causing the AV valve to open, allowing blood to flow down the ventricles passively. The atria contract to finish the filling phase, and the cycle repeats itself.
Cycle is repeating. Here in this video, they are explaining at 6 steps.
Thank you for watching. Please feel free to suggest a topic you want us to cover by leaving a...
Okay, next slide. Control. Then cardiac cycle we have learned. Then we need to understand how this cycle is regulated, controlled. And this cycle is controlled by the coordinated contraction of all heart muscles. And these heart muscles, that coordinated control, regulation, coordinated movement of the cardiac muscle is effected with the help of a conducting system. A conducting system is existed in the heart. With the under this system's control, that regulated, coordinated contraction is happening to the heart to make effective the cardiac cycle. So we are going to see the components of conducting system. It's a very important question. Control of cardiac cycle, or otherwise can also be asked as the components of conducting system of the heart. The first and the main important part is atrial node or SA node. I think you all know that SA node. First point, what is its location? Here in this picture we can see its location. It is located in the posterior wall, means it is the auricle's anterior side is the posterior side. Posterior most wall of right atrium. It is located in the posterior most wall of right atrium near the entrance of superior vena cava. This is the blood vessel that carrying blood from upper part of the body to the heart. From the heart up to our abdomen. From all those areas, the superior vena cava is carrying blood to the heart. So what about the location? Posterior wall of the right atrium near the entrance of superior vena cava is the SA node. So location we understand. Next slide. What's the function? It initiates. At the point of SA node, the impulse is initiated automatically without the regulation of any other centers. So it is in this SA node itself that impulse is starting, impulse is generating at the rate of 70 to 80 times per minute. As that impulse is starting automatically from the SA node. That SA node is called the pacemaker of heart. Pacemaker means what? Pacemaker. Pacemaker. That meaning of that word. What is the meaning? Pacemaker means whatever, whoever creating or deciding the pace, the speed of something, that being or thing, whatever it be, can be called as the pacemaker. For in the case of heart, that SA node is deciding, it's initiating that impulse. So it is called the pacemaker of heart, and it causes the contraction of two auricles simultaneously. As a result of that impulse initiated in the SA node, the two auricles contract simultaneously, means at the same time. Then from SA node, that impulse is sending to the next part of the conducting system, that is called auriculoventricular node or AV node, that we are going to see next. Atrioventricular or auriculoventricular node. SA node. Its location, let's see, it is on the floor of the right atrium near the interatrial septum. Interatrial septum. Inter means between. Inter, രണ്ട് ഓറക്കിളിന്റെ ഇടയ്ക്ക്, between two auricle. This is the interauricular or interatrial septum. Near to the interatrial septum, the floor of the right auricle or atrium present the SA node. What is its function? To conduct the impulse from SA node to next conducting system. And through this SA node, the speed of impulse conduction is very slow. That slowness have some significance. Because of that slowness, the auricle can finish it complete contraction before the ventricles start to contract. So that is why that impulse is conducting much slowly. For all events, what all things happening, there is some significance in our body system. So that slowness in conduction of the impulse through the SA node is that because of that slowness, auricle can complete its contraction before before the ventricles start to contract. That about auriculoventricular node or SA node. Sorry, SA node, AV node. It's mistake. AV node. Okay. It's a typing mistake. Next is bundle of His. Bundle of His we can see as two branch is passing through the interventricular septum. Its location. It extends to the right and left side of interventricular septum at the apex at that pointed part of the heart. That is about the location of bundle of His. It's a function to conduct the impulse very rapidly to other parts of the heart. That's the function of bundle of His. Next slide. Purkinje fibers. Purkinje fibers from the bundle of His, it is profusely branched to reach the muscle cell of heart, myocardial cell. To reach each myocardial cell, that impulse for conveying, transmitting that impulse to each myocardial cell present the last part of the conducting system, that is Purkinje fibers. Where is located? Right and left bundles of his branches to form this Purkinje fibers. Function to conduct impulse to myocardium. Myocardium means muscle cells of heart. And as each muscle cell got that impulse, they contract together and results in the contraction of two ventricles at the same time. Okay. That about the conducting system and the control of cardiac cycle. Next is about pulse. Pulse. We all used to check our pulse by pressing over the wrist. That we oftenly use and we know what's the normal rate, everything. So what's the definition of pulse? Pulse means number of heartbeats per minute. in 1 minute how many heartbeats is happening is hearing in a normal person's body. That number is called pulse. It's formation. Ventricular systole means contraction. Blood ejection to the arteries are happening. And ventricular diastole, in that period no blood ejection is happening. Need to keep those points in your mind. And here I am showing a picture of the blood vessel. This end is very close to the ventricle. Understand? And ventricle, as a result of its contraction, a small amount of blood is injected to the blood vessel, maybe pulmonary artery or pulmonary aorta, any of the blood vessel, huge blood vessel. As the blood is ejected to the artery as a result of ventricular contraction, this portion may bulge, expanded or dilated. Okay. After that ventricular contraction, next phase is relaxation. So again, as this blood moves to here, again there is a undilated portion. Understand? So first you think that this bulging initially happening to this area. That bulging happening because as the ventricle contract, a small amount of blood is ejecting to that artery, and as a result of that ejection, it wall dilated, and because of the dilated, that bulging happened, and that blood is moving to next area, and after that ventricle is relaxing, so there is no blood ejection. So there is no dilation for the wall of artery. Again there is ventricle contraction. Again blood is ejecting to the artery. Again its wall is contracting. So that movement of blood is happening in the form of a wave. In the form of a wave it is moving through the artery. Here we can, so pulse is conveyed in the form of a wave. For your understanding only, only I am explaining all these things. The pulse is conveyed in the form of a wave. Then you may think that how is conveyed in the form of a wave? For understanding that, I explained all these things. Simply for example, when it is asked what is pulse, you just only need to give is the number of heartbeats per minute. Next slide, where we are locating the pulse, and we can locate pulse at whatever point where an artery is pressed against a bone. In which all places artery is compressed against bone, at all places we can take our pulse. It may be at our neck, at the wrist, behind the knee, inside the elbow, whatever it be. So the normal values, average normal pulse in a healthy man is 72 beats per minute in man, and females it is more, 80 beats per minute. In infants it is much more, 110 beats per minute. Then there are three terms. Bradycardia is the condition. It also can be asked as 1 mark question. Bradycardia, tachycardia. Many times it is asked. So bradycardia means in such condition pulse rate is below 60 per minute. Tachycardia is a condition in which pulse rate is above 100 per minute. Abnormal condition. So some exceptional condition also there. During our sleeping time, our pulse rate can drop below 40 beat per minute. Beat per minute is normal. Don't be afraid of that. We don't think that is any abnormal condition or something is going to happen to us. Not like that. Because while during the sleeping condition, it's normal that our heartbeat can go below 40 beat per minute. And also during strenuous exercise, hard exercise, there is no chance for rising our heartbeat in between 150 and 200 beat per minute. That's about pulse. Next is about blood pressure. What is blood pressure? Pressure. What is blood pressure? It is a force exerted by the blood on the walls of the blood vessels. And that pressure is mainly refers to the arterial pressure. The pressure that is experienced by artery wall. Then it is measured by sphygmomanometer. This is the picture. We are all familiar with this instrument. Almost all have you have to show your hand in front of this machine to check the BP anytime in your life. So it's very familiar for you. And its unit of measurement is mmHg, millimeter of mercury. And there is systolic pressure and diastolic pressure. Well, we are taking our pressure, the sister or doctor may say, tell you that it's 120 over 80, your pressure is normal. That means 120 means that contraction. Contraction means systolic pressure. And 80 is the normal diastolic pressure. And normal person can have. If our pressure, if you have high BP, then it may go above that 120 level and may go above 80. Then that person to have high pressure. That's about systolic pressure and diastolic pressure. Two but margins are there for a normal pressure range. Then another term, mean arterial pressure, is the average pressure throughout the cardiac cycle. Throughout the cardiac cycle, what is the average pressure? That's called the mean arterial pressure. Then pulse pressure is there. Is the difference between maximum and minimum measured pressure. And calculating the pressure for one or more trials, and we are taking the difference. That difference is called the pulse pressure. Then we need to know the normal value. We are speaking it as 120 over 80. 120 is the systolic pressure and 80 is the diastolic or relaxation pressure. Hypertension means high arterial pressure, and it may come out because of mainly of arteriosclerosis, because of the fat deposition on the walls of blood vessels. The inner area of blood vessels may reduce and may lead to have high blood pressure inside the blood vessel. That condition is called arteriosclerosis. And in condition of liver disease, kidney disease, high blood pressure may happen. Renal hypertension means decreased blood supply to kidney may result in renal hypertension. Then hypotension means less arterial pressure. That condition is called a lowered arterial pressure. That less pressure in the body. That also dangerous. That situation is called hypotension. With this, we finished today's section. Thank you.